Hello everyone, myself Ketan Bhavsar, Assistant Professor in LJ Engineering College, Ahmedabad. In VLSI Design, Unit number 1, Introduction, and today's topic VLSI Quality and Packaging Technology. In previous session, we discussed different types of VLSI design style like field programmable gate array design, standard cell based design, and full custom design. So as per this all the design style, we recommend FPGA instead of this all the design technology, because FPGA is provide a cost effective as well as fast prototyping technology as compared to full custom, standard cell and gate array design. Now VLSI quality. Now the quality is generally dependent on different 4 parameters: testability, yield and manufacturing ability, reliability, and technology updateability. So if you go into the market and purchase any component or purchase any gadgets, so basically the quality of that gadgets or the components is depend on these parameters like testability. The component and device should be testable, yield and manufacturing ability in terms of the functional yield and parametric yield. When we're talking about the bulk manufacturing, it should be a reliable product and it should be updateability. I just give you a simple example of updateability. Like you purchase your smartphone, right? And at that time Android 9 is going in your smartphone, and after a few days if Android 10 will launch, then definitely your smartphone will support Android 10 also. So updatability is also play a main role when we're talking about the quality. Now testability. Time and effort for chip test increase exponentially with the design complexity. Definitely if your design is complex, then ultimately your testing time will be increases. The test task requires of good test vectors, definitely ability of reliable test fixture at speed, design of testable chip. So when you work on the testability, then these parameters we have to consider. We require the good test vectors, availability of reliable test mixture or fixtures at different speed, and testable chip. Now yield and manufacturing ability. When we're talking about the yield and manufacturing ability, the ratio of good tested chip to the total tested chip, it represents the yield and manufacturing ability. Suppose you manufacturing 100 chips, fine, then identify the total number of good chips which is in working form, or we can say that it fulfill your application and your requirement. Suppose out of 60% your chip is good tested, then your ratio will be 60 divided by 100. So you have to maintain the ratio as much as possible. We have to generate a good tested chip. There are the 2 types of yield and manufacturing ability: functional yield and parametric yield. Now functional yield. Testing the chip at lower speed. When we're talking about the functional speed, then we have to check our chip at a low speed. Identify the problem of short, means circuit should not be short circuited. It will not be open, means if ground is not connected properly, some leakage current because of the resistance issue. So we have to check this type of problems when we're talking about the functional yield. Detect the logic and circuit design failures. If you're talking about the circuit, then suppose we are taking one example of a voltage regulator. If you are not putting the capacitor on output side, then definitely you are not getting the proper or smooth output. So we have to check this type of fault when we're talking about the functional yield. And also logical fault is generated because of the pin configurations. You are not connected in proper manner, or we can say that you are not working or you are not doing programming well. So these are the faults we can identify with help of the functional yield. Now we're talking about the parametric yield. Test at the required speed. Now suppose if you are designing a chip which work on a 16 megahertz external crystal, then you have to check your speed at 16 megahertz. It is working properly. Delay testing is performed at this stage. So you have to check the delay with help of the PWM based signals. You have to connect the motors, you can connect the LEDs and apply the different PWM signals, generate the different delays of 1 second, 2 seconds, 3 seconds as per your requirement. And you have to check if you write for the 1 second delay, and if you're getting the properly 1 second delay, then your circuit, or you can say that your parametric yield should be worked properly. Consider manufacturability of the chip in the design phase. Sufficient tolerance to device fluctuations and margin for measure uncertainty. So when we dealing with this type of parameters, then we have to check the tolerance, means in terms of the fan in, fan out, capability of the pins, how long the pin is derived. We have to check the fluctuations margin which going on the circuit, and also the uncertainty, means it is not working on the proper manner on some time because of some issues. Maybe the ground is not connected properly, maybe your program is not working properly, maybe your connection issue. So we have to check this type of faults in parametric yield. Now we move on the next, it's reliability of the chip. Now, first of all, reliability. So it depends on the few processes and condition when we're working on the reliability. It's a reliability problems like why reliability problems generate. It's because of the electrostatic discharge, overstress. It's a main point when we're talking about the discharge and overstress. Electromigration means your PN junction will be short. Fine, then it is not work properly, so it's migration. Latch up means hold your circuit on one particular stage only. It will not work as per the clock, as per your requirement, so it's called as a latch up or hold. Hot carrier introduced egging means your IC and your component getting hot, and because of the hot it damage after some time. Oxide breakdown means in terms of the VLSI, we can say that it's a pinch off point, means your component will be damaged. Single event upset means after the single event it's again set, so it's not working multitasking applications, so it's also a problem of the reliability, and also it not work on handshaking based approach. Power and ground bouncing means I already told you, if your power is not connected properly, if your ground is not connected properly, or it will not common, then your output will be debouncing, or you are not getting the proper output. Sometime you will get the output and again sometime you will not get the output because of the debouncing effect. And for solving that issue, we always make sure that the ground should be connected properly with each and every component grounds. On chip noise and crosstalk, if you are designing very compact chip and it will be connect nearby each other, then maybe it will generate a crosstalk and it will be generate the noise. Fine, so we have to make sure that the connection should be proper manner, so it will not generate a crosstalk and it will not generate the noise. Then technology updateability. Be a technology update to new design rules. Definitely you have to allow a new design rule as per the requirement. Fast migration to the new process technology. Definitely I give you one example. If you purchase your smartphone and at that time if Android 9 is going on in the market, and after a few days if Android 10 will be launched, then definitely your gadgets, your components should support at least 2 to 3 different generation technologies, else the device will not work in market many more times, or we can say that it will not success in market. Dump string method with uniform scaling in rarely practiced. It's one of the method when we apply the scaling factor, means we have to apply the measurement, we have to apply the voltage scaling and current scaling based technique to measure the performance of the chip. Silicon compilation, generation of the physical layout from high level specifications. When we're talking about the completions, then we have to check high level specifications of the chip will fulfill your requirement. So I hope you definitely getting the idea about VLSI design quality. These are the four parameters like testability, yield and manufacturing ability, reliability, and technology updateability. Now we move on to the next topic. It's a packaging technology. So packaging technology means when whatever the chip you have and you use that particular chip, they all are based on that packaging technology. Basically we are familiar with the DIP technology, but there are the number of technologies is available in the market, and even we are using, like we see the Arduino Mega board, Raspberry Pi board. So these are all have a different packaging technologies, and we also use as per the requirement and as per the applications. Proper packaging technology is critical to the success of the chip development. Package issue has to be taken into the consideration in early stage of the chip development. Definitely whenever you start to design any product and you require the compact design style, then definitely you have to choose a specific packaging technology as per your requirement. Like your requirement, you have to make a compact chip, then definitely you have to go with the quad chip. If you go with the DIP, then ultimately your size will be increased. Ensure the sufficient design margin to accommodate the parasitics of the package. Then definitely you have to take a sufficient margin to take a parasitic values, or we can say it's a parasitic capacitance to accommodate the packaging technologies. Then important packaging concerns: hermetic seals to prevent the penetrations of moisture, thermal conductivity, thermal expansion coefficients, pin density, parasitic inductions and capacitance, alpha particle protections, and cost. So whenever we're talking about the packaging technology, then we have to take care of the moisture level concern, because whenever you design the product, then that particular product will be used in all over the world. So in each and every conditions or in each and every state, the moisture level will not be same. So definitely we have to take care of this point, and also we have to take care for the thermal point in terms of getting hot in summer or in some spaces. So we have to take care of this thing. And also in the pin density factor, because densities also play a main role for carrying the amount of current and voltages. Then particularly we have to provide the protections that it will not get the offside breakdown with help of the alpha protection. And also we have to take care of the cost when we're designing a specific chip. Types of packaging technology, we are classified by the method used to solder the package on the PCB board. It's pin through hole, surface mounted technology, DIP, pin grid array, chip carrier packages, quad flat packages, and multi-chip modules. So these all are the packaging technology that we had seen. So we definitely see the DIP chips, because your all Arduino Uno board, your 8MEGA32, 8MEGA328, PIC microcontroller 8051, they all are based on DIP. And even you can see in terms of the quad packages right now with the Arduino board, and also pin through hole and surface mounted technology we already seen in our motherboards, and multi-chip modules is also available right now, you can see in your smartphones. So these are the design that, as you can see, it's a surface mounted, it's a multiple chip, it's a pin through hole technology, it's a DIP technology, quad technology. So different types of packaging technology is available as per the requirement and as per our applications that we have to choose. So I hope you are getting the idea about VLSI design quality and also about packaging technology. If you have any doubt, then you can contact me. So thank you very much.